Mhm.
Okay, so let's wait maybe just 1 or 2 minutes until everybody joins and we get started. Okay, everyone, let's get started. I see we have about 40 and there are many people joining us, so it's a good time. Good afternoon, everybody. Welcome to our first webinar of this series. We are very happy to have very distinguished guests here with us today, and looking forward to having a very good webinar and talk and discussions afterwards. So I'm gonna just start presenting a little bit background about this webinar, our institute and the project, and then I will hand it over to Sabine to continue. Okay. Okay, so as you know, this monthly webinar series, we just announced it, and this is the first one, as I mentioned. To participate, you need to register. And so every month through the channels that we have, probably the channel that you already received this invitation for this one, you will receive the link. Please be mindful that the events happen every second Wednesday of the month. So the next one will be in January, in the second week of January. And it is fixed, the time is fixed at 2 p.m. So hopefully we will see you regularly next year, every month on this webinar series. So a little bit about our institute. So CMCC is an Italian institute based in, headquartered in Lecce, but as you can see, we have different locations across Italy. It's a leading research center focused on understanding the interaction between climate change and society. We have about 450 researchers and staff, which are distributed across 3 institutes. As you can see on the figure on the right, we have 3 institutes: EIEE, ICR, IESP. We are the one which are in Milan and EIE Institute. We also have 3 strategic programs that work across this institute, and there are cross-cutting topical basically programs. The one that is sponsoring this webinar is the one that I'm directing, integration of the planetary biogeochemical and industrial carbon cycle. By the way, sorry, I didn't introduce myself. My name is Sohail Shayeh. And as I am telling you, basically, I'm the director of this program and also the coordinator of the CDR, this uptake project. So a little bit about, a little bit about the uptake project. So uptake project is the project which started last year, and it is covering different topics related to carbon dioxide removal. And we have about 20 partners in this project that are helping us across different countries in Europe, in the EU. So For this webinar, the first webinar, you are able to interact with the presenters and ask your questions through this Q&A session at the bottom of your screen that you can see. Please send your questions there. And as I mentioned, stay tuned for our next webinar, which will be in January. Happy to have you here and looking forward to the discussion. I will hand it over now to Sabine to moderate the session. Thank you.
Thanks very much, Sohail. So my name is Sabine Fust from the Mercator Research Institute on Global Commons and Climate Change in Berlin, and I have the honor to be your moderator in today's uptake webinar. I want to start by first thanking, of course, the uptake coordinators, the colleagues at CMCC for hosting us today, and also to Agnieszka Boratinska from Reform for organizing. And then, of course, my thanks also go to our distinguished speakers for taking the time to share the expertise with us today. And then to all of you, of course, for tuning in to discuss with us on this important topic. Just briefly on how this webinar will be organized, there will be a 20-minute presentation now. And I'll introduce the presenter in a minute, followed then by a 10-minute discussion with our invited experts each. And I'll introduce them before I engage them in a discussion. And that leaves us then with 20 minutes in the end, where I encourage you very much to do what Sohail was just pointing out. Put your thoughts, comments, and questions into the Q&A box so that I can bring them up to our speakers and experts, so that they can react to that. So, having explained that, let us now turn to the presentation. I'm proud to say that Ruben Prütz is with us today and that he's my doctoral student, though of course he has long surpassed me as an expert on the side effects of scaling the different CDR options. Previously, he earned a master's in disaster risk management and climate change adaptation from Lund University. And since joining the PhD program at Humboldt University and myself, of course, at MCC here in Berlin, he has also visited Imperial College London and IASA in Austria for longer research stays. Today, he's going to present us some work that contributes to our deliverable in the Uptake project. Namely his paper, A Taxonomy to Map Evidence on the Co-Benefits, Challenges and Limits to Carbon Dioxide Removal, that was published in April this year in Communications, Earth and Environment. And as I said, feel free to put questions here as well. If there's some clarification need, I will get back to Ruben about that when he finishes. So without much further ado, Ruben, the floor is yours. Please share your screen and enlighten us on the side effects of scaling CDR.
Excellent. Thanks a lot, Sabine, for this introduction. I hope you can see my screen now. And yes, I'm very happy to kickstart this webinar series. And as Sabine already said, today I will talk about one of our recent studies, which was published earlier this year in Communications, Earth and Environment, and which is a taxonomy that maps the evidence on side effects, or specifically on co-benefits, challenges, and limits of carbon dioxide removal. This study was led by us at MCC, not to confuse with CMCC, but we also worked with colleagues at the Grantham Institute at Imperial College London. And before I start talking about the actual study, I want to give you some background. I suppose that many in our audience are quite familiar with CDR, but just as a quick recap, many of you will be familiar probably with the slide. And yeah, the slide basically shows us that by now it's quite clear that some level of carbon dioxide removal is needed to accompany deep emission cuts. This is first of all required before net zero to rapidly achieve net zero CO2 emissions. Then around net zero, it is required to balance any remaining emissions, both CO2 emissions, but also non-CO2 emissions. And then in the long term, it will also potentially be required to achieve net negative emissions to return from a temporary temperature overshoot. And as it seems, due to ongoing delay in deep emission reductions, such an overshoot is becoming more and more likely, and therefore it's also more and more likely that we will need net negative emissions to return to safer levels. So while this need for CDR is quite clear by now, there are still quite some uncertainties around the feasibility, the scalability of CDR, and also about potential side effects, potential sustainability risks, which may arise with large-scale CDR deployment. And some of these potential risks have already been studied and also documented in the scientific literature. So here's a figure from an earlier study, which was led by Sabine and published in 2018 in Environmental Research Letters, which shows that there's quite a range of different side effects. Some of them are positive, some of them are more on the positive side, but there's still quite some uncertainty. And also we have to consider that since 2018, there has been quite a growth in new literature. So here in this plot, you can see how the research field on CDR has been developing over recent years. And we can see that the literature on CDR has actually been growing exponentially in recent years. And yeah, research on CDR is actually growing even faster than climate research as a whole. And on the one hand, this is of course a good thing, because this helps us to close remaining evidence gaps, partly on side effects, but also on other aspects of carbon dioxide removal. But then on the other hand, it also makes it increasingly challenging to effectively synthesize new evidence, to keep a good overview, and also to interpret or to compare sometimes evidence that may seem conflicting at first sight. So much about the background, and this is now where our study comes in and where we try to make a contribution, because with our mapping study, we aimed at systematically identifying all the peer-reviewed English language literature that says something about carbon dioxide removal side effects, and then to effectively map this evidence to get a good overview. And I won't go too much into the methodology of the study, because I mainly want to focus on some of the results, but still just to give you a quick snapshot of what we did. So initially we started with a series of keyword queries to select relevant literature from Scopus, which is one of the largest abstract and citation databases for peer-reviewed research. And with our initial selection, we identified almost 15,000 articles which potentially were relevant or which seemed to say something about CDR side effects. So the initial selection was really quite broad, but then as a next step, we had to further refine our selection, because we figured out that in our initial set, we had quite a lot of false positives, so to say. So studies which fulfilled our selection criteria, but turned out not to be relevant in the end. So then with the help of a machine learning classifier, we further narrowed down the selection to a bit less than 1,000 articles, which are then truly relevant in the sense that they truly say something about side effects of CDR. And then in the end, for our evidence synthesis, we focused on 233 articles, primary research articles, which were published in recent years. So much about what we did. Now I'm going to move on to some of the findings. I will start with a brief overview of the relevant literature which we identified. So based on our study, we can say that not just the CDR research in general is growing exponentially, but also the subset of literature which specifically focuses on side effects, which you can see here in this plot. And actually from our study, we can see that more than 50% of the peer-reviewed research on CDR side effects has actually emerged since 2018. So it's still relatively recent. In terms of the methods, in terms of the the approaches, the composition of the research, we can see that there's already quite a variety of different study approaches, while currently quantitative analyses and modeling studies sort of dominate the composition of the methods. So for example, this includes scenario studies produced by integrated assessment models or life cycle assessments and these kind of studies. But we also see that there's already quite a large research body containing reviews and meta-studies, and then to a smaller extent also field experiments. So for example, this would include studies on biochar side effects or soil carbon sequestration, so basically effects on soil implications. And then to a smaller extent, we also have surveys, interviews, or more qualitative conceptual deliberations, which, for example, focus on perception or acceptability. So much about the general overview. Now I want to dive a bit more into the content of the different studies, because our aim was to really provide a good overview of what is being discussed in terms of side effects in the literature so far. And here in this plot, you can see 18 overarching side effect categories, which we identified across 6 different CDR options. So in our study, you can see this here on the horizontal axis, we focused on afforestation and reforestation, on bioenergy with CCS, biochar, then direct air capture with CCS, enhanced weathering, and soil carbon sequestration. So these are the 6 CDR options that we considered. And then in addition to these 6 options, we also considered more option unspecific deliberations. Or like also, considerations or side effects which are relevant for several different CDR options. And then here on the vertical axis, you see the 18 different effect categories which we identified. And just from looking at this plot, we can already see that there's quite a lot of research already going on for afforestation, BECCS, and biochar in terms of side effects. So this is represented by the size of the bars, while for direct air capture, enhanced weathering, and to some extent also soil carbon sequestration, there's currently much less research on side effects. In terms of the composition of positive versus negative side effects, we can generally see that there's a predominance of negative effects represented by the red bars. But for some options, especially biochar, we can also see some positive side effects, so also soil carbon sequestration. I think here, when looking at this plot, it's very important to reflect that this is not a robust real-world reflection of the composition of positive and negative side effects, but this is simply really just a reflection of what is being researched and already documented in the literature. And so the picture may also change as new evidence then arises. And I think it's also important to reflect that the different studies that underlie this analysis here have very different contexts, very different deployment scales for CDR, and so on. And these are all relevant factors when it comes to understanding the side effects. So I think the main learning from this plot is that there's really still quite some uncertainty, but also some variety, in some cases, negative side effects, or for the same category, there may be both positive and negative side effects. And I think exploring this further is quite relevant to eventually, hopefully, reduce the negative side effects and foster some of the more positive implications. Moving on, in addition to these effect categories, we also wanted to understand how the evidence on side effects is distributed geographically. And this you can see in this plot. And here we can learn that currently there's still relatively little site-specific side effect research focused on countries or regions in Africa or South America. And this is quite interesting because at least in many of the climate change mitigation pathways, which were also considered in the latest assessment cycle by the IPCC, these regions or these continents are actually deemed quite crucial for land-intensive CDR deployment. So this lack of site-specific research then also points to a potential research gaps, because we, of course, first should better understand potential site-specific implications before we can really safely roll out CDR projects. Then next, I want to highlight that in our study, we identified almost 400 individual side effect categories across the different studies that we reviewed, with very granular data for each of the 6 CDR options. And then our approach was to systematically group these different side effect categories into different categories based on thematic similarity. And then we also aggregated this into a taxonomy, which you can see here. It is quite small to read, but this doesn't matter. I won't go too much into detail. I just want to highlight the concept here. So here in the center, you can see the 18 effect categories, which I already mentioned. So this is at the higher level of aggregation, and then we have more detail for each of these categories and then more detail. So our study goes really into depth in the different areas, and this then also allows us to compare the different options. So we can, I would say this is not necessarily useful for comparing the side effect profiles, but at least it's helpful to compare what research gaps there may still be for the different options in terms of side effect research. And yeah, there's much more detail in the paper, so I invite you to check this out. And yeah, I still want to go a bit more into detail, but of course, covering 400 individual side effects is a bit tricky in such a presentation, which is why I think it makes more sense to look at it at a more aggregated level, because we identified 5 overarching dimensions, so to say, 5 overarching dimensions of potential overconfidence in CDR or potential constraints to CDR deployment. And now I'm going to quickly go through these dimensions. So the first dimension, which we derive from our taxonomy, is readiness. And this means that we really have to be careful with overestimating the readiness and scalability of CDR options, because from literature evidence, we can see that already now there's a growing deployment gap, meaning that already now we are off track to reach the levels of CDR that are required by mid-century to be in line with Paris-aligned mitigation pathways. So this is definitely a dimension of potential overconfidence. But similarly important is the aspect of permanence and resilience. And in terms of permanence, we mean, or it is quite clear that storing the carbon that is removed from the atmosphere safely and durably is really key to effectively balance the warming effect of fossil emissions. And especially in the context of net zero targets, which countries put more and more forward, recent evidence from the literature, actually also from an uptake study, shows us that durability of at least 1,000 years is required to effectively balance fossil emissions. However, some of the CDR options, which we often discuss, also in this study, so for example, afforestation and soil carbon sequestration, these options are characterized by much shorter permanence timescales. And in addition to the permanence timescales, there's also the issue of resilience, because we know that in the context of continued climate change, there will be more heat waves, more droughts, potentially also more pests, and this then in turn can threaten some of the carbon which we store in soils or in biomass. So yeah, this explains then why this is another potential dimension of overconfidence. In addition to this, we have several system feedbacks. I call this unintentional system feedbacks, which may offset some of the cooling effect of CDR. So here we think, for example, of unfavorable albedo changes, which lead to additional warming and would then offset the cooling effect of CDR. Or this could also include, for example, indirect land use change, which then may trigger emissions in other places. So for example, if we aim to sequester CO2 via afforestation in a certain location, we have to change the land use, and this may then trigger land use changes in other places with additional emissions. Then another very important dimension of overconfidence is around policy response and governance. And here from the literature, we see that the sheer outlook of a future CDR capacity may actually lower today's ambition. And yeah, this of course is a very risky strategy, because we of course should not bet on a future CDR capacity, partly because of the other dimensions of overconfidence, which are already mentioned. And here it's also very important to reflect that monitoring, reporting, and verification, which is really key to measure CDR and the contribution to mitigation, is, at least as of now, not ready to sufficiently monitor CDR. And then the last dimension of potential overconfidence is about sustainability and acceptability. As you may have seen in the previous plots from the taxonomy, we have really identified an array of different sustainability concerns or side effects. They are very CDR option and context specific, but some of the very relevant ones in terms of effect size, but also relevant because they pertain to different CDR options, are water demand, land demand, and fertilizer demand. And this in turn then may also have implications for biodiversity, conservation, or food security. And yeah, these side effects then also explain why acceptability for large-scale CDR deployment may actually be low. There's still a research gap here. We know that the general awareness for the role of CDR in mitigation is still relatively low. Also, there's some support for CDR deployment, but I think once we start to roll out CDR in specific places, I think acceptability or public support may also be potential constraint, which is often not considered, for example, in scenario analyses. So much about the findings of our study, and also this addition about the different dimensions. Before I close, I want to highlight a few synthesis challenges which we had, which can be understood as some of the limitations of our study, or potentially also advice for future studies which try to further improve the understanding of side effects of CDR, because there were several trade-offs which we had to deal with. First, there's really a large diversity in study types, which I already showed you before. So, for example, modeling studies, life cycle assessments, field experiments, and so on. And all of these different study types contain very important side effect information. However, there's a trade-off of selecting all these different study types, but at the same time also ensuring a like with like comparison, which is difficult when you want to have the diversity in study types to be as large as possible. The same is true also for the different analytical scopes. So for example, we have different scopes, plot level analyses, for example, in the context of biochar or soil carbon sequestration. Then at the city level, we may have more life cycle assessments, and then at the country and global level, some scenario studies. And again, all these different scopes are relevant to understand side effects of CDR. But again, it's not always easy to then effectively and consistently compare the side effect related information for these studies. Another trade-off is then, or the question whether it should be such a review study should aim for a qualitative overview or more quantitative effect size assessment. So in our case, we really went for more qualitative overview to effectively and comprehensively scope the current research. But if you would like to go more into effect size comparisons, then one also has to deal with quite a diversity in reporting approaches. So some side effects report the effects per removal, per area, per time, or per capita, which again, all is relevant but hard to compare. And then the last point before I want to close is that there's really quite a diversity in analysis contexts, so different baselines where CDR is implemented, different configurations of the individual CDR options, and the deployment scales, of course, play a role regarding the side effects. The deployment locations, and ultimately also the deployment scale. So I think our study is really just a starting point to scope what is already being documented, but there's still lots of work to be done to further synthesize and effectively compare side effects across studies. With that, I want to close. This is my last slide. Here is also the QR code to our paper with the full list of effects. So feel free to check this out, but I hope we will also have time in the end to pick up some of the questions. And yeah,
Thanks.
with that, I hand back to Sabine. Thank you.
Yeah, thanks very much, Ruben, for this comprehensive overview. There's a couple of clarification questions by Giulia Lupiani in the Q&A box, and also by Andrea Cavina. Because we are quite progressed in time, I would ask you, Ruben, to take up these questions and answer them directly in the chat box so that we can continue with our panel. And then later on, we can see whether we pick some of this up in the discussion. So let me introduce our experts of today's panel. We have with us Fabiola de Simone, who is Carbon Market Watch's policy expert on carbon removal. Welcome. She has a focus on climate governance and EU targets, and she's previously worked as a government affairs manager on EU energy and climate policies for a trade association in Brussels. She's also been with both the OECD and DG Agri and holds a master's in public policies from Luis Guido Carli University in Rome and a bachelor's in political science and international relations from the University of Naples, L'Orientale. She's thus perfectly suited to share her thoughts on what our topic implies in terms of policy requirements. And I will engage in a little bit of a discussion with her after I've talked to our second panelist, who is Dr. Sylvia Vetter, who has been working at the Environmental Modelling Group of the School of Biological Sciences at the University of Aberdeen in the UK since 2012 already. She holds a doctorate from the chair of meteorology at the Technische Universität Dresden in Germany. And Sylvia is really an expert in modeling greenhouse gas emissions from agriculture, grasslands, and land use change, and specifically impacts on soil organic carbon, and things that you've heard from Ruben about, and possible mitigation options, including biochar. We've actually been collaborating on the assessment of side effects of different CDR strategies. So Sylvia is very well posed to add here to our discussion on the role of science. And I will actually start with you, Sylvia. So I just introduced you as an expert on soil carbon sequestration, and that's actually often lauded as one of the CDR methods that has quite a lot of co-benefits. I mean, Ruben has been talking a lot about potential sustainability risks of scaling CDR, but soil carbon sequestration often stands out as coming with a lot of co-benefits, as also Ruben's illustrations showed. Do you see that confirmed in your work? Do you see actually still gaps in the published literature that Ruben has had a look at? And how do you see your role in advancing the knowledge base for the decisions that have to be made now in terms of policy, in terms of what practitioners set out to do? So what's your take?
Yeah, thank you, and hello, and thank you for inviting me to speak today on this interesting topic. So when it comes to soil organic carbon and the soil carbon sequestration, I'm talking more about the side from the agriculture and grassland. So I'm leaving the forest and afforestation part out of it. So increasing soil organic carbon in agriculture, as we know, through a management change or a practice change, comes with different challenges, but also co-benefits, as well as some challenges from the other side. And depending on the practice and managements that are changed to increase, so either to increase the organic material or maybe reducing the disturbance to the soil, there can be other benefits and trade-offs as well, as Ruben mentioned before. So there are many papers, and Sabine mentioned we are working together, and this is actually a larger effort on a review on the different CDRs, and I'm part of the soil carbon sequestration group, which is led by Pete Smith here at the University of Aberdeen. And in the moment, we are going through 17,000 papers to see actually the benefits. So also on the potential, the cost side, what is quite well covered so far, what we could see, but also looking at nutrition side, so what side effects basically we are looking for. One would be the nutrition side, the water availability, also water holding capacity from the environmental side. Then there are other impacts, and Ruben was showing this all really nicely. So we are also trying to cover the social aspects or policy aspects of things, what is a little bit more challenging to find in literature. So what we know, there's more research out there, but really doing a systematic review on all of this. We are in the middle of it, and we see there is more and more research emerging. But it will be challenging bringing everything together and really show the full picture of it.
Excellent, thank you. So the role of science, not only in coming up with the new original research, but also actually providing the synthesis of the evidence to make it usable. Now, you already mentioned this community effort, the ecosystem of reviews, where the different expert teams on different CDR options are trying to follow their the same protocol in doing a systematic review, so that we come up with comparable, thorough, detailed, and repeatable reviews. Now, you are also leading a kind of cross-cutting effort across these different CDR teams, looking specifically into the side effects. So you have a very good overview of what's going on in the different categories, not only soil carbon sequestration. And I would be interested in your impression of where the research landscape is really moving. Is our understanding of side effects really improving, or are you saying, yes, we're looking into these thousands of papers, and we're going to provide the evidence synthesis, but actually what we need is now projects and pilots in order to learn more about side effects as we implement them? What's your take?
Well, the short answer to both would be yes. So there is definitely more emerging and more work on it, that we see much more on reporting on co-benefits, trade-offs, even if it's not called side effects. So we see more in it, but there's also much more needed on all the work. So specifically, I mean, when we have the different CDRs, and we're talking about the potential, so that's usually really when you deploy them in the field. But when you look on the whole life cycle of one CDR, so there come much more impacts and effects, so the side effects as well. So when we are, for example, if it's biochar, where are the fat stocks are coming from, or for enhanced rock weathering, where's the, if you really upscale, where's all the rock dust coming from? And so there are more research done, and there will be more coming out. The question is, can we cover this all now in the reviews? And so each of the teams are looking in the moment and doing their research, and at some point we will come together in the side effect group and try to synthesize everything, so that we can hopefully provide something that is comparable between all the different CDRs.
Yes, I think that's super useful work, because as you, I mean, this is also basically what we will need as we're coming up with the new generation of scenarios to see how this will then play out at scale. So yeah, thanks for leading that effort. We'll come back to you as more questions come in from the audience. But in the meantime, I want to return also to Fabiola, because we also want to touch base on the policy dimension. So you're the policy expert for CDR at Carbon Market Watch. And do you think side effects of CDR, as we saw covered in Ruben's presentation, are rather a showstopper? He's been talking a lot about the risks, how it also negatively affects acceptability and so on. Or do you think co-benefits could also represent an entry point for scaling certain CDR methods? What's your take from your perspective?
Thank you very much, Sabine, and hello everyone. Thanks for having me today. That's a very good question, and I think that the topics of today's webinar is extremely relevant for the discussion on how and if we can rely on carbon removals to tackle climate change. Before answering the question whether I see these side effects as being a showstopper, just to put things into context, as Ruben was saying at the beginning of this presentation, we know now that there is a wide acknowledgement by the scientific community about the need for carbon removals to supplement emissions reduction. So we need to slash and reduce our emissions as fast and as much as possible. This is unavoidable, but at the same time, there's also a need to counterbalance those emissions that for societal or technological reasons we won't be able to eliminate. So there is a need to prepare for a sustainable removals capacity. And so today's presentation, that paper is really important in understanding about how much actually CDR, how much sustainable CDR can be and how much we can rely on them. So I think that we should move towards a more supply-driven approach to carbon removals. We know that considering all the side effects that are identified in the study, the amount of sustainable removals will be and is scarce, and we should rather look at the feasibility of it instead of looking at it from a demand side perception, and also maybe so understand better if we should rather being even more ambitious with our goals to reduce emissions. So I think that yes, for some methods, if there is enough evidence that some CDR methods actually lead to very detrimental impacts, then I think that they should represent some showstopper for some methods. But at the same time, I think that these challenges, as well as the co-benefits, also represent an opportunity to maybe look at what is more promising, where risks can be better mitigated, and how also we can improve regulations and policy so that we can better reduce these risks.
Thanks. So a strong plea for a supply side focused approach here as well. Now, from a policy point of view, and then looking at the kind of research landscape that Ruben mapped out in his presentation, do you then think that we know enough to move ahead? So this is a question a little bit allowing you to address also what Sylvia was saying. What's your expectations towards science? Are there gaps from a policy perspective that still need to be filled, or do you think we have a knowledge base that already allows us to get started?
So I think, so the paper summarizes very well the existing literature on CDR side effects, but it also shows that there is still limited and often mixed knowledge on CDR side effects, benefits and challenges. And there's certainly a need to expand our understanding of this in order to inform policy. I think that a thorough assessment of each CDR method is critical to make sure that there is at the end real climate benefit, and that benefit doesn't jeopardize other sustainability aspects and environmental aspects. So research is critical in this regards, but at the same time, I think that we can already move forward in the policy landscapes with some solutions that are trying to already mitigate some of the risks and the challenges that Ruben was tackling in his presentation. So I think that, for example, robust policy governance of CDR is a way to help in this regards, and more specifically, starting with separate targets and policies for emissions reduction and then removals, and then further distinguishing between removals methods is, for example, helping reducing the risk of mitigation deterrence, and also giving more clarity to project developers, and enhancing transparency and accountability of the targets. So I think that there is a lot to do in the context, in the policy landscape already, and there's also a need to differentiate better between the roles and the different potentials of permanent removals. And Ruben was saying that permanence is a key element for making sure that removals actually are effective to mitigate climate change, and those methods that instead rely a bit more on natural ecosystems. And Carbon Market Watch believes that these two categories are a little bit different in the context of the natural-based solutions. We saw also from the paper that they have more potential to have positive co-benefits for biodiversity, for ecosystem services, and we should be able to enhance that part rather than looking at it merely as a storage of carbon. Whereas for the permanent removals, we also saw that we have still limited studies on those methods that rely and that are based on geological storage. So more research is needed there, because we know that we need permanent removals for residual emissions. We hope residual emissions will be as low as possible, but we still need them. So I think that area is also extremely relevant. And I think from the scientific community, it's very important to pass the message to policy that, and as Ruben, I think, was saying at the end of the presentation, we really can't over-rely on CDR to avoid the catastrophic consequences.
Thanks a lot for mapping out the challenges also in the policy landscape, not only in the research landscape, and also for offering actually quite concrete thoughts on how that could be tackled. I have a final question for you, though, going a little bit to the international dimension. And specifically because we're just looking back at a recent COP and at these discussions around Article 6.4 in Baku. And I mean, there was a lot of criticism to COP leadership for moving quite fast on this. Do you think side effects feature sufficiently in the considerations around the governance architecture of trading carbon credits? Because a lot of what we saw in Ruben's presentation actually has quite some relevance for this debate as well. So if you have some thoughts on that, yeah. I know many people are wondering, so we would be very curious to see what you think.
Yeah, indeed. And actually, this third question allows me to say something I forgot about your second question about policy, which is, as also I think Ruben was mentioning, we need also robust rules regarding MRV and certification of removals, and knowing a bit more about the side effects helps then refining these rules about specific methods. When it comes to Article 6, so just as for an update, during the last COP, during the COP29, the document, the standard prepared by the supervisory body of Article 6.4 was adopted, which gives guidance on activities that cover removals within Article 6.4. We believe that that document is flawed when it comes to defining ensuring permanence, the permanence of removals. This is because there is no definition anywhere of the durability or a minimum time frames of storage of the removals activities. There is a requirement for project developers to monitor, to do some monitoring and reporting during the post-crediting period, so after the credits are issued. But actually, there are ways for the project developers to get out of this responsibility. One is based on how negligible is the risk of reversal of the activity, but there is no definition on how we will define this negligible risk. And also the use of buffer pools, that we know that from the voluntary carbon market experience, they can be really, there can be many loopholes and don't work very well. So just to be a bit short, and on a more positive and maybe optimistic side, there's also some part of the document that instead requires the project developers to apply some sustainability environmental requirements in line with the sustainable development tool, that was also adopted before the COP, the tool for Article 6.4. And this tool is requiring project developers to conduct a risk assessment of the impacts, of the negative impacts, and where necessary, trying to avoid and minimize those impacts. But of course, as everything, the devil is in the detail, and we don't know how thorough this assessment will be. This assessment will be reviewed by external, by third-party verifiers, but we don't know how much, how really serious and how these principles will be interpreted. We don't know how the verification will actually be conducted, but at least some principles are there, and that's a positive outcome.
Thanks very much, Fabiola. Very interesting. So yes, I already opened it, opened the floor to the audience, encouraging them to ask questions. And I had one coming in for Sylvia. Specifically, whether you could talk about some of the specific risks related to land-based CDR that may have been overlooked or underemphasized in the literature, and that we should be on the lookout for, especially against the background of what Fabiola was discussing just now.
Well, usually most of it is the positive that is highlighted in the literature from the different CDRs. What I realized is missing often is the full life cycle when it comes to the different CDRs. So there, especially if we're just talking about the potential, it's usually just talked about the potential that is actually when you deploy the different methods, but really looking on the whole greenhouse gas balance, maybe when it comes to the full life cycle, that is often missed. So in some of the publications that are out there on different ones, it's really hard to compare them, as some consider the full life cycle, maybe a half life cycle, or other aspects are totally missing. So they are just looking at the impact that the CDR is having at that moment. And from the side effects, it's everything else, basically. So it's really, really hard to see what is missing in the moment, because it's Ruben had this really nice big graph. There's so many effects that are already partially, at least, in the literature, and where we can have some impression from of it. But when it comes to policy and what all the information they need to really make a decision, there can be much more into it, especially when it comes then also to the maybe social impacts as well. Will there be more employment, maybe less employment? The land that is needed to actually large scale. There are some CDRs that don't require more land. Some would need more land. Where is all the energy coming from, for example? So there, some is already there. But I think really looking at the overall of the whole life cycle is much more important when it comes to the different CDRs. And if going forward, if something is reported, this needs to be considered.
Yeah, but I shared that impression about, I mean, the taxonomy was like, had a huge kind of like list on the environmental side effects, and then the social and economic part was considerably smaller. So yeah, that was also something that sprung to my attention. Now, in the meantime, Ruben has been doing a splendid job in answering a lot of questions about the presentation. Ruben, is there anything that you want to raise to everybody's attention? You now dealt bilaterally with most questions, but maybe there are some interesting points to bring to all of our attention.
Yeah, there were some clarification questions about the selection of literature. And I was a bit brief about this in the presentation, but basically we had like a full list of different criteria that needed to be fulfilled to be included or also like excluded. First we defined a set of selection criteria, then we identified potentially relevant literature with our queries, and then we really went through the different studies to check if they align with the criteria or not. And you can check out this criteria in full in our supplementary material. I posted this in the chat, but some of the key criteria that needed to be fulfilled was, of course, that the studies would have to say something about one of the 6 CDR options which we considered, or CDR in general, so option unspecific, and something about side effects. So and this needed to be highlighted in the abstract. So if side effects are just mentioned somewhere hidden in the discussion, then we would not consider this. The articles needed to really focus on this and provide new insights to be considered in this in our evaluation. I think in terms of other questions,
there are more coming in for you as we speak. So I'll leave you to that, and thank you, and turn back to Fabiola. So Nick Fitzpatrick is asking a question: how to prevent double counting of CDRs. So you already highlighted a couple of concerns, but double counting is also typically one. He has an example as well, and maybe you have some thoughts on that.
Yes, sure. Thanks for the question, which is also very relevant. I am not myself really focusing on Article 6. I have other colleagues, but I can give you some an answer of what I think. So first of all, I think we should, in the voluntary carbon market, move towards a contribution claim approach. So we shouldn't allow companies to use carbon credits to offset their emissions, but to reach net zero, but to say that they are contributing to their country NDC. So this is already a way to try to mitigate that risk. And then in the context of the UNFCCC and Article 6, we should adopt the approach of corresponding adjustment, whereas like that itself tries to avoid double counting when credits are exchanged by countries, for example. So yeah, that would be my short take.
Thank you very much, Fabiola, for this. We're almost at the top of the hour, so I'm afraid anything that's coming in right now, we will have to deal with that by email. We will definitely collect everything that couldn't be addressed here. But I think the richness of the discussion showed that there is a lot of interest, a lot of gaps to be discussed. I want to thank Ruben as the presenter, but also Sylvia and Fabiola being the panelists today, giving us their expert opinion. I'm sure you're available if people want to reach out about any of those topics you let us in on. And with that, let me also thank the audience for being so engaged and our hosts for organizing the seminar, and close this. Yeah, it's always a bit odd to moderate something that's online, because then it's sort of like gone. If you're in person, you still see the people and can chat a little bit as you're walking out. But I'll give back to Sohail to actually end it abruptly.
Yeah, thank you. Thank you very much, Sabine. Thank you, Ruben and also the panelists for the great discussions. I was following both the discussions that we had live and also the questions. Some very interesting questions came up, and I can tell you that stay tuned. This series has just started. If there is particular topic that you like to hear more from the experts, please don't hesitate to reach out to us, and we will try our best to get an expert who can answer your questions and present in that. We have a very nice platform for doing that. So if you are staying just a second with us, I will just share for a second the screen, and then it allows you to scan the QR code and you can basically join our platform. So just okay, so here we go, and this is the QR code that you can scan and join the platform that we have. It is UPTAKE CDR Forum, a stakeholder forum, and it allows you to see the ongoing research from the UPTAKE project. As I mentioned, you can see the list of partners and also follow the news about CDR. So we are trying to provide information, general information about CDR, the latest publications, and also going a little bit into the policy dimension and so on, provide a discussion forum for all the interested parties. So hope you enjoy this, join our platform, and follow us next month with the next webinar. Thank you very much, and see you next month. Bye.
Thanks a lot.
Thank you. Bye bye.